Okay, so this is where the fun begins. We have learned how to add all these different functional groups. We've learned about their directing abilities for adding the second functional group. We've learned how to convert one functional group to another. So let's start now looking at target molecules that we might want to make that have some of these functional groups on them, and figure out the best way to make them. So let's start with chloronitrobenzene. And think backwards. How would we make these? How would we add these two groups on? What order would we add them to get the product that we're interested in? So first of all, you notice that they are in a meta relationship to each other. And so that means that the first group that you add had better be a meta director, so the second one will add in a meta position relative to the first. So this chlorine right here is an orthopara director, and the nitro group is a meta director. So we're going to have to add this nitro group first and then add the chlorine second. So the last thing that we are going to do in this synthesis is to add the chlorine after we have already added the nitro group. And we'll do that by adding Cl2 and iron trichloride as the catalysts. And then we're just working backwards one more step to benzene, adding the nitro group by adding nitric acid and sulfuric acid. The reagents for these should be second nature by now. You should have memorized them and used them enough that you don't have to wonder what you would add to get a nitro group on there. Okay, so that's the thought process for that one. Let's do another one. How about we have a chlorine again, and instead of a nitro group, we have an ethyl group attached. Okay, think through the process. The relationship between these groups is a meta relationship. This chlorine is, as we already said, an orthopara director, and this ethyl group right here is, what kind of director? Orthopara again, so we have a problem. Houston, we have a problem. Okay. Now think back to converting one functional group to another. We could make this alkyl group from an acyl group, which is a meta director. So we could initially add this acyl group, and then after we add the acyl group, that is a meta director, then we could add the chlorine, and then we can convert this acyl group into an alkyl group to make our final product. So see how the thought process is going there. When you once you've kind of thought through whether you draw it backwards the way I did here or forwards isn't so important, because you've thought through all the steps and the order of the steps before. And so that's really what you're doing here, is thinking backwards first to figure out what do you have to add first before the other, and then realizing that you have to make that from something else, and then you can go through the entire process. So I'm going to start drawing it from benzene, and we decided the first thing we wanted to do is add this meta director here. So Friedel-Crafts acylation here, aluminum trichloride, and put the ketone on there. And then that is the meta director that's going to direct the chlorine into the meta position, and there's two meta positions here, and they're identical to each other. It's symmetrical, so you only get one product there. So chlorine and iron trichloride gives you that product, and then you just need to chop off the carbonyl there, and there are a variety of different ways to do that. Hydrogen and palladium is the easiest one to do that. Okay, good. So let's have you do the next one. Have a benzene ring with, I feel like I'm getting stuck with chlorine. Everything's chlorine, chlorine, chlorine. So I guess I can convert that to a bromine, and let's add a propyl group, and so para relationship. So go ahead and pause the video, figure out a way to make this, and then start up the video and we'll talk about it. Okay, so you've gone through the process. These are in a para relationship. Bromine is an ortho-para director, and the propyl group is also an ortho-para director. Okay, so no problem at all, right? We just add one and then we add the other. Does it matter which one we add first? Probably not. There's going to be some crowding going on in the ortho position, which might favor the para, but either way you're going to get a mixture of both the ortho and para products from this. There is a problem though. Did you find the problem? Remember, you can't add a propyl group by Friedel-Crafts alkylation because it's going to rearrange to an isopropyl group. So this must be added as an acyl group. Okay, so when that is added, it needs to be an acyl group. And it can be added first and converted to an alkyl group and then this bromine added, or the bromine added first and then do Friedel-Crafts acylation and then reduce it after that. So either one of those methods will work. Step number one, 1, 2, 3, aluminum trichloride. One, two, three. So we added the acyl group there. Then we can't add the bromine until we convert it to the alkyl group. And we're doing that by hydrogenating it, hydrogen palladium, and then we can add the bromine. So that's one way to do it, and then the other pathway would be to add the bromine first, So there's not always one best way to do it. Sometimes there's two good ways to do it. Then add our acyl group, Friedel-Crafts acylation, orthopara director, directing in that position. And then reducing it to the alkyl group by hydrogen and palladium. One problem that I'm kind of ignoring here, that I shouldn't be ignoring, is we are forming the para product, and either here or at the end, this is the para and then plus ortho. And so you can't avoid the ortho. Maybe there's some crowding going on because bromine is big and this group is big, and so you'll get mostly para. But in the end, you need to separate the para from the ortho.